Today's lesson is a continuation of yesterday's lesson on calorimetry. This diagram shows a typical classroom calorimeter. There will always be cups, water within the cups, and a thermometer to measure the temperature changes. The chemical system will be placed in or dissolved in the water of the calorimeter. In more advanced laboratories, bomb calorimeters are used. These actually have a bomb placed inside the water surrounding the bomb. The materials inside the bomb are ignited and the water temperature change is recorded. This graph shows how the energy lost in the exothermic reaction between zinc and hydrochloric acid is transferred to the water in the calorimeter. As one goes up, the other goes down. The reason why we do calorimetry is to determine the change in molar enthalpy of the reaction. Change of molar enthalpy is written with a delta H. In a calorimeter, the change in molar enthalpy is equal to the energy taken in or released from the water. In our calorimetry problems, we need to ensure that we separate information about the reaction and the calorimeter. The calorimeter side will always involve mc delta T of the water in the calorimeter, and may include mc delta T for the components of the calorimeter. The reaction side uses delta H, or the change in molar enthalpy in combustion, reaction, or solution reactions, but may also use mc delta T in specific heat capacity or mixture problems. When a reaction occurs, there is typically an enthalpy of reaction or a change in enthalpy. This refers to the energy change of the whole system and is not specific to a reactant or product. The symbol has a small r written in between the delta and H. It is measured in kilojoules. Molar enthalpy of reaction is different in that it is written per mole, and it is for a specific chemical in the reaction. When we are using molar enthalpy, we will also include a small m. Enthalpy can be converted to molar enthalpy by dividing by the number of moles of the specified chemical. Enthalpy of reaction is written with an R, but depending on the type of reaction, different subscripts may be used. If we want to use molar enthalpy in our equation, we can, but we need to rewrite the equation with the molar enthalpy being divided by the number of moles. This is essentially the same thing as multiplying by the enthalpy of reaction. This is the end of our lesson on calorimetry. We will be going over some examples of calculations in class.